So I'm going to start the video here today. We're talking about complex numbers, and I asked the students to consider what real numbers were versus imaginary numbers, because that kind of plays into today. Real numbers are simple things like 5. Imaginary numbers are things like the square root of -7 or something like that. That's like an imaginary number. If you put a real one together with an imaginary one, then that's called, take a guess from the title of the notes, complex. That's called complex numbers. A complex number has a real part and an imaginary part, but this imaginary part always has to have an I on it. Do I just stick an I on it? No, I'll show you how to do that in a second. So that's our job for today, is to create complex numbers which have a real part and an imaginary part. All right, so let's dig into that imaginary part a little further. What's the square root of 4? 2. They're equal to the same thing, aren't they? They are the same thing, right? All right. Now, here's a really common misconception. An extra smart kid thinks isn't it actually plus and minus 2? No, it's not. You got that from when there's a variable like this, and then you went, and then you went, and then your teacher unfortunately wrote, and that made you think that square roots have 2 answers, and they don't. Really what the teacher should have done right there is said, this is the absolute value of x. And I did that wrong until a math teacher corrected me on that. An older math teacher when I first got here said, you're doing it wrong. And she was right. It's the absolute value of x, and this one is 4. So now a ton of kids that are extra smart will think, oh, the answer is plus and minus 2. No, it's not. The square root of 16 is just 4. What's the square root of 4? It's just 2. It's not 2 things. It's just 2. Just 2. That's it. Okay. So then how about the square root of 8? Would you please simplify that? You learned how to do that earlier this year. When I say simplify, basically it's like you're trying to make it into like 4 root 3. That's not the answer, but... it's root 4 and root 2. And then that's 2 root 2. Raise your hand if you had that one right. Excellent. Okay, good. You remember your basics of square roots. So what if I made it not just square root of 25, square root of -25? The way I imagine this happened, there was a guy, was a math teacher, who was like, what are we going to do with these square roots and negatives? We know that they can't exist, but we want to be able to simplify them. I mean, first of all, why can't it exist? Well, because 5 times 5 would equal 25. And -5 times -5 would also equal 25. So what the heck can we do to make it so we can actually simplify this and get an answer for it? And no, the answer isn't just, we'll just say it's 5, like the square root of 25 would be, and then you slap an I on there. That is not what he did. It's similar to what he did, but what he actually did was he said, we could break this into 2 square roots, just like we broke the square root of 8 into root 4 and root 2. We can break the square root of 25, the square root of -25 into 2 things. We can say it's the square root of 25 and the square root of -1. Do you get so far that what he said was logical? Because this times this would equal that. You good with that step? Then he said, we can define that as a variable. We'll just call that I. Kind of like somebody at one point said 3.14. Let's just call that pi. Do you get, from then on, nobody ever uses pi as a variable anymore? Pi is always 3.14. Have you ever thought about that? It's a letter, but it's not like, I'm going to stick in 5. No, it's 3.14. It always is. It'll never change. So math teachers have always agreed that pi, this Greek letter, will always be 3.14. It's not a variable. You can't vary. Well, I is the same deal. We picked I to be special. I is the square root of -1. So then when you write square root of 25, which is 5, I for this, people aren't confused, if you know math, you aren't confused and think, oh, you mean 5 times a variable. No, it's not a variable. I stands for the square root of -1. Now, the really intriguing part to me is that math like this, which somebody made up, is now needed to make equations for the flow of electricity. Since it was invented, they have invented equations that will allow them to, for instance, like put circuits on a board. You guys have seen those computer chips that are like really complicated little nests of circuits all on a wafer of silicon. All right, you've got them in your phone. All right, those things, there's electricity flowing through that, right? And the equations for the electricity that flow need I to be able to work. They couldn't have designed your phone unless somebody had figured out I. Isn't that kind of weird? They took an imaginary thing and it works so well that it's used in the real world for the flow of electricity. Okay, so back to, what does a typical question look like? Well, here's one that should be a slam dunk for you. Square root of 81, duh, it's 9. So what if I stick a negative in front of it? It's not that hard. It's going to be 9i. But where did it really come from? Square root of 81 times the square root of -1. And that's I, and that's 9, so it's 9i. All right. Here's the little first stretch. Square root of -40. Simplify that down as far as you can, and yes, of course, there's an I involved. I'm going to pause for a second while you give that a shot. Well, I'll take it over from here. Some of the students didn't know. I'm going to break it into the square root of -1 and the square root of 40. As a first step, do you guys agree that that could be a first step? Okay, awesome. And then the square root of 40, couldn't that be the square root of 4 and the square root of 10? Uh-huh. And that means that's I, that's 2, and that can't be simplified anymore. I know some people are thinking root 5 and root 2. No, it's not any simpler. Neither one of those is perfect square. So this is 2i, and that's how you write it, root 10. 2i root 10. Now, nobody told you how to write that. Now that is an imaginary number. And it's a complex number if I write 0 plus in front of it. I know that seems weird, but to have a complex number, you always have a real part. There isn't anything real about it. And an imaginary part. Imaginary, real, put them together. What's that called again? Complex. That's what a complex number is. Got a real part, imaginary part. All right. Now let's go back to this. This is absolutely one kind of question that you will see not only on your next test, but also on the ACT test. They like to throw in problems with I because it's, well, some kids just think that's a variable squared. If you never had heard of complex numbers before, you would think it's just I squared or I to the third. But you know that this actually doesn't just mean I, it means the square root of -1. Then what does that mean if I square it? That means the square root of -1 times the square root of -1. And if you're extra smart, you could figure out what that's equal to. Last hour, I think there was only 2 people. Talk to the kid next to you. Try to figure out what do you think it is? Any idea what that would be? Okay, somebody take a guess. Just guess. -1. Any other guesses? 1. Those are the 2 logical guesses. Probably either -1 or 1. So now I'm going to tell you it's one of those two. Now I want you to take a side. Talk to the kid next to you. What side do you think it is?
You were close to the one part, right? You just like added a little something. It's not a variable, so don't go for it. I think he just negative. Just
Who is on team 1? Raise your hand if you're on team 1. Who's on team -1? All right. It's close to half and half. Isn't that interesting? All right. Well, here's some. I'm going to give you not the answer. I'm going to give you a different problem, and that should tell you what the answer is. The square root of 5 times the square root of 5 is 5. Think about that for a second. Isn't this actually square root of 25? Which is 5, right? Okay, so now, with more information, you can repick what side you're on. It was about half and half. So now, are you on team -1 or are you team 1? Raise your hand if you're on team 1. And who's on team -1? That side grew, and you were right. It's -1. Because what's underneath the root, that's what the answer is. Like if I said the square root of 1.2 times the square root of 1.2, that'd be some weird number, I don't know, but then it would be that squared, and then you take the square root of it, and so it's 1.2. It's whatever's underneath the root. And what's underneath the root? -1. All right. Now, I tutor kids to try to get really good scores on the ACT. I think I got 5 kids now up to a perfect 36. I'm proud of that. For other kids, one of my favorite ones was helping a kid get from a 17 ACT to a 22 ACT, because for him that meant getting into the college. The 17, he got denied. They said, sorry, can't let you in. We got him up to a 22, and he got into his college that was close by his house, and it was cheap, and he really needed that. So I'm actually more proud of the 17 to the 22 than I am of the 36s. But I'm still kind of proud of the 36s too. And one of the things I can make kids memorize is that I squared is -1. And you'll see later this hour, that's the key. That's the secret to almost all of complex numbers comes down to this, that I squared is -1. If you were going to ever write something down, that would be the one to write down right now, that I squared is -1. It's a big deal. It'll help. It'll help a lot. And I'll show you why. Because then, when you get to I to the third, you can go, well, isn't that I times I times I? And then isn't I squared just -1? He just told me that 2 seconds ago. So this whole thing, I squared, that's -1. And then -1 times I would make -I. Or -1I, but I'd just rather -I. And then you're going to be starting to see I squareds everywhere. Do you see I squared times I squared? I do. I squared times I squared. And what's I squared? -1. So then it's -1 times -1, which is 1. See how you can keep getting answers for this? Because you can keep saying, well, it's a whole bunch of I squareds, really. With an extra I. What's that? I squared. What's that equal to? -1. That's another -1. -1 times -1 times I. Isn't -1 times -1 just 1? And then times I, which would just be I. And that's weird because that's what we started with. And so here's the weird progression. I, then when you square it, it's -1. Then when you put it to the third, it's -I. and then it's 1, and then it goes back to I, and then the next answer is going to be -1, and it recycles those same 4 over and over and over and over. Okay, that's weird, but it's true, and it's not even that useful. What's really useful is if I give you I to the 7th, you have to just be able to go, that's a whole bunch of I squareds. It's I squared times I squared times I squared. Am I done? No, I got one more I. And that's a whole bunch of -1 times -1 times -1. Take a second and write what you think the final answer is to I to the 7th. You've been listening to me for too long. I squared? You know what that is. Another I squared? Still the same thing? Another I squared? Talk to the kid next to you. What do you think the final answer is? Negative I is correct. -1 times -1 times -1 makes negative I. Negative I. And some people like to put a 1 in there, and it's legal. -1I is the same exact thing as negative I. It's just not quite as clean. I would prefer negative I. All right, cool. Now, I betcha, without even telling you how to do it, you can multiply this out and apply what I just told you and figure out the answer. And if you leave I squared in it, I will be very disappointed. So it's got 4 parts of the answer. First, outside, inside, last. Did you do that part? Raise your hand if you did that part. Okay, good. 2 times 2 is 4. That's what you'd start with. And then there's more, of course. There's 4 parts. And I said, and I'll say it again, if you leave I squared in your final answer, I'll be disappointed because you're supposed to know what to replace it with. All right, talk to the kid next to you. See what you think they got. Or what did you think it was? Carlos, you're one of my star students. So you got 4. And you got a 2i and a 2i, which makes 4i. And then you got an I squared. I know I could get you to tell me all that, so I'll just start with that. Now what do I do? Yup. 4 minus the 1, which makes? Now I'm curious. Did you write it as 4i plus 3, or did you write it as 3 plus 4i? And why is that better? Because the real part comes first. Remember, these are complex numbers. You got a real part, you got an imaginary part. We've talked, and in this unit, because this isn't super critical, my colleagues wanted, I sometimes disagree on these things, that's okay, but we have to kind of agree on how we're going to grade the tests. We're going to accept either one of these. I personally think we should stick to this because I don't think it's that hard to remember. Just put the real part first. But we're not going to mark this wrong if you switch them around. I mean, it's possible we'll change our mind this year, but last year we had a big talk about it. A lot of people were like, it's not that important. Okay, fine. But I think you should try to remember to put the real part first, okay? All right. So, the last melon. The last thing I have to teach you. And then It's work time. Okay. You ever heard of don't write this, but have you ever heard of x equals negative b plus or minus square root b squared minus 4ac all over 2a? Who remembers that? It's in the deep recesses of your memory. Good. Then was a teacher a long time ago who taught you that little song to help you remember this formula. That is to solve a quadratic. It's called the quadratic formula. And if a quadratic like this is set equal to 0, then you can use that little formula and it will solve it. Now, you don't have to even know all that today. But when you see this and we ask you to simplify it, you'll know where it came from. Might be like, other than that, without this context, you might be like, why in the heck is there a plus and a minus in the middle of the problem? It's from this formula that's a famous formula. So here is your simplified problem. You should see one thing in there that you immediately know. I know this one. He did this one in class earlier. And then you might get stuck. If you get stuck, I want you to remember that I told you that when about half the class gets stuck, it's usually this. And for those at home, I'm tapping on the poster that says, if you can factor it, you should. Simplify this down as much as you can. I know this is a good problem because like 5 of you, maybe 3, are going to actually figure it all the way out. Half of you will get it halfway done, but get stuck. And that's cool. That means it's a hard enough problem. If in the honors class, everybody gets them right all the time, there'll be something wrong with that. And if everybody gets it wrong, there's something wrong with that too. This will be just right, where some of you will get it right, but not many. So one step at a time. Do you see the one thing that we already did this hour? There's one thing you can simplify in here. How many of you see the one thing you can simplify? Raise your hand if you do. Awesome. They are talking about that, and that is what? 5i. Now comes the harder part. Finish it. 5 plus 5i over 10. Like I said, not many people will get this all the way. But if you got it, I want you to be able to be the kid who showed the other kid, like, here's what the right answer is. So go on record. If you think you've got it, show the other kid. All right, so now I'm about to show you, and then now that you showed somebody else, you went on record, maybe somebody else got this, which would be amazing. All right, this part can be factored because they both have a 5 in them. So I'm going to rewrite this 5 plus and minus 5i over 10. Okay, and this part they both have a 5 in them. What does that mean? That means I can divide them both by 5 if I also times by 5 in the front. That's how you factor it. Now I've got 5 factored out, and what's left on the inside? This tells me and this tells me. 1 plus and minus I. All over 10, but 10 is really 5 times 2, isn't it? And if you can factor it, you should. So Those cancel now. 1 plus and minus I over 2. Raise your hand if you got that far. I am impressed. 1, 2, 3, 4, 5 students. 6. It's more than I thought. I thought it'd be 5 or maybe as low as 2. Do you get what just happened there? If you didn't get it before, but you get it now, that's the key, because there'll be a problem just like this. All right. So let's try another one. 6 plus and minus square root of negative 36 all over 18. That part should be a walk in the park to go, well, it's got to be 6i. Awesome. Then they both have a 6 in them. Talk to the kid next to you. What do you think you got? What do you think they got? Mr. Breen, can you tell me what this simplifies to? Factors to?
6, and in parentheses, 1 plus or minus I.
Nice. All over. Might as well factor it right now. 6 times 3, and those cancel, and there's your answer. 1 plus and minus I over 3. Raise your hand if you had it right. Awesome. That's almost everybody now. That's fantastic. Okay, now I want to stretch your mind a little bit further. Because they're both being divided by 3. Did you know you could split that up into 1 over 3? Plus and minus, what do you think I'm going to say? I over 3. And what would be better about that? Because then you got your real part completely separated from your what part? Imaginary part. And that's what makes a complex number. See, you can, I'll just give you an example of this. 1 plus 3 over 4. If you've never thought about this before, that's 1 over 4 plus 3 over 4. Either way, don't you get 4 over 4? This way is 4 over 4. Wouldn't that also give you 4 over 4? You can do that. If you got a plus like this, you can split it up into 2 parts. The 1 over the 4 and the 3 over the 4. Okay, so we could write this answer here as this answer here. Now, are you required to do that last step? Nope. Another one where we're not going to be that mean. I could see a really strict Mr. Kerbopple who says, sorry, kids, I told you. You have to write it like this. Real part, imaginary part. But we will take this answer on the test too. Okay? All right. Last one. If you can do this, you've got the hardest stuff. And if there was only one thing you remembered today, it should be that I squared is what? -1. Okay. 4 plus and minus square root of -16 all over 6. Ian, can you tell me what just this part is? 4i, very good. That's a good start. Okay. Next. Wrecker. There's two of you. There's two people that share the same first name, but we're going to go with Miss Wrecker, not Miss Reader. Can you tell me, how do you factor this part? Actually, just divide them by 4. You're not wrong that you could divide a 2 out, but you really should take out the biggest thing that you can, and you can take out a 4. So let's divide them by 4. And then you have to also, what do you put in front? A 4. There's the factoring thing, and the 4 comes out front now. Now, let's hand it off to the next person. Mr. French, what's the first part? Plus and minus the second part.
1 plus I.
Plus and minus. I, very good. All over 6, but we're not going to use 6 because if you can factor it, you should. And the 6 could be factored to 2 times 3. And why is that handy? Because this 4 here could be factored again into 2 times 2. And then the 2's cancel. And you're left with that. That is as difficult as they can be. That's pretty tough. All right. Remember, I've told you this before. Day 1 of the unit, you just learned like half the test. Like the upcoming test. Tons of stuff you just learned are on the next test. So if you feel a little bit like I don't get everything, that's normal. If you got everything on day 1 and it's half the test, then the rest of the unit will be really boring. So, you know, don't expect that you're perfect yet. Let's get started on the Schoology quiz together, and then I'll hand back your test that you just took. In the big picture, if you got a B, you may want to do corrections, because you know how you can get a better grade on the cumulative test that's coming in like 2.5 weeks or so. So you probably would want to start corrections today. All right, numero uno. Steichen, can you read me number 1? I cubed, very good. And I like to think of that as I squared times I. I'm going to give you that little scaffolding. That's the same thing, isn't it? And Carlos, why did I break it up with an I squared in it? Exactly, and what's the final answer if that's -1? Negative I, and that is what you type, and that is the correct answer. Now remember, I is always, it's not a variable. I is a number. It is the square root of -1, but this is what you type. All right. Alice, can you tell me number 2?
Square root of -8.
I would break that into 3 square roots right out the gate. Matt Breen. No, sorry, that's your dad. Mr. Breen is safe to say. Jack, what did you get for one of your square roots? You could make it an 8, but I think I'd break it a little further than just 8. There we go. Square root of 2, square root of 4. And what's that last square root? Somebody say it. -1. Good. And then you have to be smart enough to know what this really is and what this really is. And I hope you knew that that was 2 and I, and then square root 2. But since we're on a Schoology quiz, you have to type SQRT, parentheses, 2. 2I, SQRT 2. All right. I hope that you'll be brave enough to ask the kid next to you, hey, what'd you get for number 3? Before you hit submit on this thing, if you get stuck, or come up and ask me. That's all I got for you for today.